Morning, my dear students. How are you today? I hope you're fine. Today we're going to start our new book. It's called Geometry. Let's start together. So, this is the first chapter here, Foundations for Geometry. We're going to have, understanding points, lines, and planes, explore properties associated with points, measuring, constructing segments, measuring and constructing angles, pairs of angles. Then we are going to have the coordinate and transformation tools, using formulas in geometry, midpoint and distance in the coordinate plane, transformation in the coordinate plane, explore transformation. So let's start now lesson 1. So, understanding points, lines, and planes. I have here some objectives. By the end of the lesson, I have to know all of these, okay? So, by the end of the lesson, I will be able to, identify here. As you see here, by the end of the lesson, I'll be able to identify, name, and draw points, lines, segments, rays, and planes. Apply basic facts about points, lines, and planes. Okay, so objectives here to know what I'm going to study from this lesson. Okay, so as you see here, I have this table. I have a point. A point is what? A point names a location and has no size. And I know that all of you know this information, but it's important to know, to ensure that you have got all the information now. A quick review about the point. The point here names a location, and has no size. It's represented by a dot, as you see here. I have here name, a capital letter, point P. This is the name. A line. A line is a straight path that has no thickness and extends forever. As you see here, I don't have here an end point, so it goes forever. This is called a line. A lowercase letter or 2 points on the line L, we can say here it's called here L, or XY, or YX. A plane. A plane is a flat surface that has no thickness and extends forever. As you see here, this is the plane. A script, capital letter, or 3 points, not on a line. Plane R or plane ABC. So it's called here plane R or plane ABC. So points that lie on the same line are collinear. New information here I have. Points that lie on the same line are collinear. So K, L, M are collinear, right? And I have here KLN, R, KLN. Change the color now. We have here K, L, and N here. So are they collinear? No, they are non-collinear. Why? Because they are not on the same line, as you see. Points that lie in the same plane are coplanar. Otherwise they are non-coplanar. Here ABC are coplanar, and if I have here a point outside, it's not a coplanar. So example 1, naming points, lines, and planes. As you see here, refer the design in the roof of Beijing's national stadium. Name 4 coplanar points and all lie in plane R. As you see here, I want the marker now. So I have here L, M, R, and K. They all here lie on the plane R. So they are coplanar points. And we have here the other question here. Name 3 lines. Name 3 lines here: AB line, and BC line, and CA line. Very easy now. Let's go. So I have here a segment or line segment that 2 end points. So the 2 end points here, it's called the line segment, as you know. It's easy. Is a part of a line consisting of 2 points and all points between them. An end point is a point at one end of a segment or the starting point of a ray. This is an endpoint. So C is a capital letter. It's an endpoint, and D also it's an endpoint. Array as you see and as you know, all of us know this information, it's endpoint and any other point on the ray. So I have here endpoint and any other point on the ray. I have here RS ray. Opposite rays are two rays that have a common endpoint and form a line. Okay, the common endpoint and other point on each ray. I have here EF and EG. So I have here EG as you see from this point, and I have here EF. This is called opposite rays. Okay, dear students. Okay. Drawing segments and rays. Draw and label the label of the following. I have here a segment with endpoints UMV. So this is a segment as you see. Okay, it's easy. I know all of us know this. And I have here opposite rays with common endpoint Q. When I say opposite rays with common endpoint, I have here common endpoint Q. So here I have opposite two rays as you see. Okay, opposite two rays. Okay, so after this, a postulate or axiom is a statement that's accepted true without proof. Okay, dear students, this is a new information. So a postulate is, or an axiom is a statement. This is a statement that's accepted as true without proof. Postulates about points, lines, and planes help describe geometric properties. Let's see. So I have here postulates. Through any 2 points, there is exactly one line. As you see here, through any 2 points, there is exactly one line here between them. Through any 3 non-collinear points, there is exactly one plane containing them. As you see, this is a postulate, okay? If 2 points lie on a plane, the line containing those 2 points, of course, is what? Of course is, can you hear the word of course is? Yeah, of course lies in the plane. When I say it's of course lies in what or whatever, of course, sure it will be like this. So it's a postulate, okay? Okay. So identifying points and lines in a plane. As you see here, name a line that passes through 2 points. I have here, there is exactly one line N. As you see, we have here just one line which here passes through 2 points. So I have here line N passing through G, and as you see, G and H. Line N, and this line is called N. This line, all of this line is called N. Passes through G and H. Okay. Okay. So here I have the intersection. The intersection is the set of all points that 2 or more figures have in common. You know, the intersection of any 2 lines or any 2 figures now. The next 2 postulates describe intersection involving lines and planes. So postulate here intersection of lines and planes. If 2 lines intersect, so again here intersection of lines and planes. If 2 lines intersect, then they intersect in exactly one point. As you know, this is very easy, you know this information. If 2 planes intersect, then they intersect in exactly one line. So new one, 2 planes intersect, it's very easy. They intersect on, yes, one exactly line. Use a dashed line to show the hidden parts of any figure that you are drawing. A dashed here line will indicate the part of the figure that's not seen. Okay. Representing intersection, as you see here in example 4, I have here sketch a figure that shows each of the following. A line intersects a plane. As you see here, a line L is here intersects a plane but doesn't lie in the plane. Okay, but doesn't lie in the plane. Here I have 2 planes intersect in one line. Okay, they intersect here on one, yes, in one line. Okay, this is the line of intersection of the 2 planes, the purple and the green one, and here I have the line intersects, yes. Okay, then I have here some exercises. Okay, and we have to here solve some exercises first after we go to the next after we go to the next lesson.